Well, hi everyone. I have this practice test here, and we'll just jump right into it. It says, for each subset described, I'm going to read the directions, sketch the subset on a number line, express the subset as an inequality if it's in interval notation, like these, or in interval notation if it's an inequality, like these, and then state whether the subset is bounded or unbounded. All right, so number line, number one, x is less than or equal to 7. Let me put 7 right down here. 6, 8, 5, 4, 3, 2, 1, 0, negative 1, negative 2. Okay, x is less than or equal to 7. So I'm going to put a closed circle on 7 and a heavy arrow to the right. And even the point of the arrow I'll make a little heavier. And then it's in inequality form, so we are going to change it to interval notation. The left bound is negative infinity. It doesn't have a left bound. The right bound is 7. It's included. We never put a square bracket on infinity or negative infinity. And like I said, it doesn't have a left bound, so this is an unbounded interval. Okay. Okay, so I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Got more than necessary, but that's okay. Negative 3, I'm going to put an open circle. It's not included, but it is the endpoint, and this endpoint is included. Heavy line between those two, segment between those two would be, and it is an inequality, so I want a open circle on, it's an open circle, so I want a curve bracket there and a square bracket there. And this one's bounded. It has 2 endpoints. This endpoint's not included, this one is. Alright, now we have interval notation here, so let's first of all represent it on a number line. Got negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Negative 2, I'm going to put an open circle. 5, closed circle. And then shade between them. It is bounded. It has 2 endpoints. All right. Negative infinity to 6 on a number line. Let's go 6, 7, let's go 5, 4, 3, 2, 1, 0, negative 1. On 6, I'm going to put an open circle. That's the right side. The left side is negative infinity. So I'm going to go like this. And as an inequality, I would go x is less than 6. And it is unbounded. Okay. Number 5, simplify the expression with positive exponents. Okay, I'm going to look at it as 12/4 times a cubed over a to the negative 2nd, negative 2, and b to the negative 4th over b. So 12/4 is 3. Power of a is 3 minus negative 2. You subtract in quotient, and then negative 4 minus 1, and then that's 3a, 3 minus negative 2, that is 5, b to the negative 5th, but we want positive exponents, So what I'm going to do is write that as 3a to the 5th times 1 over b to the 5th, which is 3a to the 5th over b to the 5th. This one, I've got 5c to the negative 5th times 4 to the 2nd times c cubed to the 2nd. So I got 5c to the negative 5th times 16 times c to the 6th. So you're looking at 5 times 16 times c to the negative 5th times c to the 6th, just rearranging that a little bit. And that is 80, and then it's negative 5 plus 6. And I'm maybe showing more steps than you might, but 80c to the first, or just plain old 80c. Now number 7, I'm going to simplify this one, and that's 36 times 2, or 36 is 6 to the 2nd power times 2, and this is times a to the 4th squared times b squared times b to the 4th. And I'm trying to get these squares and square roots, as many as I can in here. And then if I separate all these, I got square root of 6 squared times square root of 2 times square root of a to the 4th squared times square root of b squared times square root of b. And square root of 6 squared is 6. Square root of a, I'm going to do these first, where I can cancel the square and the square root. And that's square root of a to the 4th squared. The square cancels out with the square root, so I'm left with a to the 4th. The square and square root cancel. I'm left with b to the 2nd here. And then what did not get removed here, I'm going to put under the radical. Okay, I do want to make one point here. If this problem were a little different, and it were 72 a to the 6th, b to the 5th, you'd have your 6, and this would be a to the 3rd, and this would still be b squared, and then square root of 2b. But the reason I did this, this would be a to the 3rd squared. That's the part I changed. I would, to be 100% accurate, that would have to have a square root, not square root. I have to have absolute value. We need that to come out positive. A negative value substituted in for a should still have a positive value out here. So, and when you raise that 3rd, if it was negative and you raise the 3rd, it's going to be negative. Here, if the a were a negative value substituted in, when you raise it to the 4th power, that's still going to be positive. So it's not necessary here. It is here. It's not necessary around here. That's not necessary, those absolute value bars. So I'm just making that distinction here. Now, on this one, I'm going to do this step here, cube root. I'm going to take negative 1 cubed. Negative 1 cubed is negative 1. This is 27 times 5. And 27 is 3 to the 3rd power times 5. I'm going to go times x to the 3rd power times x squared. And what do we have here? The cube root and cubes are going to cancel out. So I got negative 1, 3, and x are canceling out with the cube root. And then the cube root of 5x squared. And with a cube root, I do not need to worry about them. The negatives are fine. No problems. On this one, I am going to go 2 times square root of 16 times 3 is 48. So I'm going to go 4 squared times 3 minus 3, and here I'm going to go 3 squared, which is 9 times 3, and then square root, so it's 2 times square root of 4 squared times the square root of 3 minus 3 times the square root of 3 squared times square root of 3. I'm just separating those. So we got 2 times 4 square root of 3 minus 3 times 3 square root of 3, which is 8 square root of 3 minus 9 square root of 3. These are like terms. 8 minus 9 is negative 1 square root of 3, or just negative square root of 3. All right, number 10 needs a little rationalizing in the denominator. Now that's 1 over the cube root of 5 times 5. In order for me to do this right, I need another 5, and I just inserted a 5 in the denominator. I need to insert a cube root of 5 in the numerator. So I've got the cube root of 5 over the cube root of 5 cubed, and those will cancel and give me the cube root of 5 over 5. Now here I've got two terms in my denominator, and so I'm going to use the conjugate, square root of 2 minus the square root of 3, to multiply the numerator and the denominator by. And my top, that's 6 times the square root of, 6 times square root of 2 minus 6 times square root of 3. Okay, you just distribute. And then I'm going to go 2. Square root of 2 times square root of 2 is 2. The other stuff's going to cancel, but square root of 3 times square root of 3 is 3. So 2 minus 3. So I'm looking at 6 square root of 2 minus 6 square root of 3 over negative 1. And if I put both these over negative 1 separately, I would have, this is negative over negative, I would have 6 radical 3 minus 6 radical 2. Just think about that. That's negative 6 radical 2, and this is positive 6 radical 3, if you distribute that negative 1 to those two terms. All right, number 12, we want exponential form. It's radical form now. We want exponential form. This is a cube root, and it's not x cubed. So I have 3 times x to the 2/3 power. Now x to the first is x to the 3/3. I'm going to add the 3/3 and 2/3 and make that 5/3. Now that is exponential form. I'm going to go radical form here, but what I'm going to do first is write it with a positive exponent. This is one of the ways to do it. There's other ways to approach it, and then I'm going to write 1 over square root of a cubed. And you can put the 2 here, you don't have to. And I'm going to simplify this a little bit. That's a squared times a. It's 1 over a square root of a. Square root of a squared is a, and then I still have that. And I did not, in order for this to work, a is going to have to be positive. It's got to be positive under the radical. It can't be 0 either, because 1 over 0 is undefined. Now, what I'm going to do now is rationalize this. I'm going to put another a there, and a square root of a up there. So I basically put the square root of a, and this is the square root of a squared. So it's a times the square root of a squared, which is a times a. So I'm looking at the square root of a over a squared. Now, 14. I'm going to rearrange things. I'm going to take 4 times 3 times x squared times x to the negative 1/3 times y to the 3/2 times y to the 1/4. 4 times 3 is 12. And then I've got x, this is 6/3, to the 6/3 minus 1/3 power. Y to the, this is 6/4. 6/4 plus 1/4. Just getting that common denominator there in those exponents. And 6/3 minus 1/3 is 5/3. 6/4 plus 1/4 is 7/4. Okay. If it is in exponential form, let's have our simplified version be in exponential form. If it's in radical form, I want my simplified version to be in radical form. What I'm going to do on this, 27 is kind of something I recognize as a power. It's 3 to the 3rd power. That's going to make it simpler, I think. And now, what I'm going to do is change this. That's the cube root of 3 to the 3/4 power. See that? And then I'm going to, that's 3 to the 3/4 power. And instead of cube root, I'm going to go to the 1/3 power. And power to a power means I multiply, so that's 3 to the 1/4 power. And I said that I want it in radical form, so that's the 4th root of 3. And there's my final answer. Now number 16. I'm going to combine like terms. Addition, subtraction, we combine like terms. 3x squared minus negative 2x squared. That's 3x squared plus 2x squared. Minus 5x. This is minus 3x. And 7 minus negative 5 is 7 plus 5. And so I got 5x squared minus 8x plus 12. 5x squared minus 8x plus 12. So there is my combining of the like terms. This one I'm going to FOIL. It's multiplying. X times 3x is 3x squared. X times 2 is 2x. Negative 4 times 3x is negative 12x. Negative 4 times 2 is negative 8. So I'm looking at 3x squared minus 10x, combine these like terms, minus 8. Final answer. Number 18. I'm going to kind of use the extended distributive. I'm going to multiply everything by x first. 2x cubed, and I saw some other styles, and I'm fine with those. Minus 3x squared plus x. Negative 6 times 12x, that's negative 12x squared. I'm going to line it up with the negative 3x squared. You can write it all on a line if you want, but negative 6 times negative 3x is positive 18x. Negative 6 times 1 is negative 6. So it looks to me like we got 2x cubed minus 15x squared plus 19x minus 6. Now to do number 19, x plus 3y cubed. I am going to figure out what x plus 3y squared is first, this way. There's other ways of approaching this, but I'm going to just use this way first. And then that's x squared first. Outside is 3xy, and we'll work on shortcuts with these two. Inside is 3xy with the patterns, and last is 9y squared. So I'm looking at x squared plus 6xy plus 9y squared, and I'm going to multiply that by x plus 3y. And x times x squared is x cubed. X times 6xy is 6x squared y. X times 9y squared is 9xy squared. And 3x squared times 3y is 3x squared y. 6xy times 3y is 18xy squared. And 9y squared plus 3y is 27y cubed. X cubed plus 9x, x squared y plus 9x squared y plus 27 xy squared plus 27 y cubed. That's what I'll stick with for my answer here. When I'm doing this one, number 20, I think I'll take y minus 2 minus x. I'm going to take those parentheses out. Y minus 2 plus x. Nothing to distribute on those, so I'll just write it like this. And y times y is y squared. Y times negative 2 is negative 2y. Y times negative x is negative xy. I'll write in alphabetical when I have to do that. Let's do the negative 2. That's negative 2y. Negative 2 times negative 2 is positive 4. I'll line it up if I can. And negative 2 times negative x is positive 2x. Now, x times y is xy. So I'll go plus xy. X times negative 2 is negative 2x. And x times negative x is negative x squared. I don't see it lining up with anything. I'm looking at y squared minus 4y. Those cancel. Plus 4. And then those cancel. And then minus x squared. Now, I do want you to kind of keep something else in mind here. If I have a problem like this, I can treat it, if I treat this just as a single variable and this, an expression grouped together, instead of separating it into two terms like I did here, I can take y minus 2 squared minus x times x, or x squared. First squared minus second squared, the difference of squares, that like when we were doing conjugates. And then there's a shortcut here. I can take y squared minus 4y plus 4. If you square this, if you take y minus 2 times y minus 2, you're going to get this. It's first one squared times 2 times the first term times the second term, and then the last term squared. And then I still have this minus x squared, and if you notice, I got the same answer. All right, there we go.